But still, that spring forward really messes us up.
Oh, I know, that hour. All right, so the graph of a function is given. Use the graph to answer the question. All right, so so we're reviewing from all of chapter 3, 3.1 through 4.2 that we just finished. This is what's on the exam in a week. So we'll do like part of it for half an hour, and then we'll do the rest next time. Let's take a look at number 1 there. So can you do that? Let's see what you remember. Let me give you a second. Okay. All right, let me help. So f of 20. Remember, so the whole key, there's nothing to solve. It's just reading a graph. The key to reading a graph, which you might want to put in your 3x5 card. Right now, let me encourage you to be putting on the side the things you want in your 3x5 card. You want to make your 3x5 card based on the things you need to solve the practice exam, right? Because I always make my solemn promise, the real exam will be just like the practice exam. So if you know everything in that practice exam, you're ready to go. The real exam will be not dumbly similar, but still somewhat similar, right? Different problems, but the same amount and the same types. So anyway, f of x, right? Normally that's how we see functions, right? So that helps us know that the 20 must be the x. And what it equals is the y. That's the key you need to know to reading a graph. What's in the parentheses is x, what it equals is y. So the x is the 20, so find the dot on that graph that's at an x value of 20. Now, notice how this is 50 here, right there. So each of those marks must be 10, right? 10, 20, 30, 40, 50. Okay. So what's the dot that has an x value of 20? Right there, huh? That's 20. That's the x value of 20. And what's his y value? Yes, it's negative 10, negative 20, negative 30, negative 40. So that's negative 40. So the answer, it's none of those? That's a hard one to start off with, huh? Wow. It's negative 40.
Yeah, that's why I said this is
Yeah, it is goofy. It's none of these. Does that make sense? I know it's a little disturbing, none of these questions. So, does that make sense? So f of 20, when x is 20, the y value going with x 20 is y value negative 40.
because I don't remember doing it that big on the homework.
Just like that. Questions? We good? So the key is to remember x goes into the parentheses, y goes out. Find that dot on the graph that has an x value 20. Find the y value going with it. All right, number 2. Here's another one to try. For what numbers x is f of x equal to 0? Key, this is x. Obviously, it says x. And this is y. So find the dots that have a y value of 0. Boom, and boom, and boom. All those are at a height of 0. All those have a y value of 0, don't they?
Oh, it's y 0.
Right? Y. So that's the key to reading a graph with function notation. The key is they're seeing, do you understand that x is what goes into the parentheses and y is what it equals? So when they put 0 over here, they're saying, find me the dots that have y value of 0. All 3 of those dots have a y value, a height of 0, don't they? Right? This one is 50, 0. This one is, what is this one? 10, 20, 30, 40. Looks like 35, 0, yeah. And what's this one? Like negative 30, 0, because it's negative 10, negative 20, negative 30. So what are these? So that's the x, y, x, y, x, y. Yeah, it's that one, huh? Negative 30, 35, and 50. Are we good there? So I try to fool you now so you won't be fooled on the real deal, right? So you'll nail this in a week, right? That good? So x is what they put in the parentheses. Y is what it equals. That's the key. It's f of x equals y for function notation on a graph. All right. Number 3, find f of negative 1. That's pretty easy, right? Yeah. Can you do that real quick? All right, so we just plug in negative 1, huh? And remember, whenever you plug into a function, you want to put parentheses around what you're plugging in, like that. And so negative 1 squared is positive 1, regular 1, right? Negative 1 plus 2, so this is going to be what? Minus 7 over 1. Minus 7? Good there? All right. Number 4. Now, number 4 is for sure on our exam. because this is called the difference quotient, and it's something they'll show you in pre-calc, and if you go on, it's in calculus. It's the first thing you do in calculus 1. That's why they're showing it now. So it's for sure going to be on the exam we take, this next exam. So try that. See if you can do that. So remember, you first need to find f of x plus h. Here's the function. It can get lost. There's the actual function we're talking about. It's a little confusing. It almost looks like that's one of the answers or something. That's actually the question. It's take this function and plug in x plus h. Boom. And then subtract the whole f of x and then divide it all by h. Do you remember some of that? Help. So what is f of x plus h? Whatever's in the parentheses, you're going to plug into the toaster in both his x's. Remember, the x in a function is the holes in a toaster. It's where you plug the stuff in, huh? So it'll become x plus h squared plus 6 x plus h plus 4. All of that is f of x plus h minus, so all of that, minus, and then f of x, which is x squared plus 6x plus 4, all entirely over h. And then I got to work all that out. Do you see what I did there? So this right here is f of x. This right here is f of x plus h. So I took this function, x squared plus 6x plus 4. Remember, these x's are insert slots, aren't they? They're holes where you plug in whatever's in the parentheses. What's in the parentheses for the first part? X plus h. So I plug in x plus h in both these spots. See it all there? Mm-hmm. And then I subtract all of f of x. See how this whole first part here is f of x plus h. It's the function with x plus h plugged in. And this back part is f of x. We good so far? Now I got to work all that out, which is not easy. Let me come up here and do some of it up here. I got a little more room. So this first part here, x plus h, x plus h, that's x plus h squared. Remember when you have a 2 on parentheses, it means 2 of those parentheses, and then you got to go first to both, second to both. Remember that whole thing? I remember my daughters took a long time to get that straight when I was helping them take these kind of classes a few years ago. So when you have x plus h squared, my daughters always wanted to go x squared plus h squared. I sat at the kitchen table with them for hours, and we doing their pre-K. They were taking another professor out at Fresno City College, and they'd have a question, and we'd be doing their homework. They'd go, Dad, we want to do math homework. Can you sit with us? And they would do this, and then they would write that. I'd go, no, girls, that's still not true. I must have said that like 10 to 20 times. No, girls, that's still not true. They go, oh, yeah, that's right. We got to write 2 of them. Because they wanted to get into Cal Poly. They wanted to pass their math class well. So you got to write the 2 parentheses, right? And you got to FOIL that out. So make sure you remember you got to write the 2 parentheses and you got to FOIL that out. So you take this first to both. So x squared plus xh, and then the second to both, plus xh plus h squared. So first to both, second to both. Is that good? So you can master this stuff. Just take some practice. There was a time when I thought that I couldn't do any of this stuff. It just takes practice. So then let's simplify that. xh and xh is 2xh, huh? Because that's really 1xh and 1xh is 2xh plus h squared. We good there? Is that making good sense? So that's all just this. That's just that first part. Is all that. So let's bring that down. That's x squared plus 2xh plus h squared. We good to there? Plus, and now the 6 multiplies through the x plus h, 6x plus 6h plus 4. And then the minus sign is going to distribute through this. Boom, 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 right? Minus x squared, minus 6x, minus 4, all over h. Is this making sense? So you can do this. You just got to practice this a couple times on your own. And it'll be just like this, I promise. It'll be, instead of x squared plus 6x plus 4, it'll probably be x squared plus 3x minus 2 or something. It'll be very similar, very similar. Just practice this and you can do it. And we have the other practice exam that changes the numbers every time for you to give you more practice. So now a bunch of stuff's going to cancel, right? So remember, everything that doesn't have an h cancels. That's whenever you're doing this difference quotient. That's what I always tell my calculus students. Everything without an h will cancel. So x squared, he doesn't have an h. Then he better cancel or I messed up the algebra. Yep, there he goes. He cancels. 2xh, he has an h, so he's hanging around. H squared, he has an h, he's hanging around. 6x, he better go bye-bye. He doesn't have an h, does he? Yep, there he goes. 6x minus 6x. Yeah, it's an easy way to catch any sign mistakes because they should cancel. And positive 4, negative 4. Sure, see all the non-h terms drop out. They always do when you do the difference quotient. So what do we have left here? 2xh plus h squared plus 6h all over h. Now what do you do on the last step? Yeah, the h cancels one of the h's from each of these guys. 2x plus h plus, or you could factor it out and cancel. Same thing, right? So it's d. And that's the way it'll be on the real exam. It'll be d. I'm just kidding. It won't be d, but it'll be the same kind of question.
Is factoring easier?
In other words, it's when we could have just, I don't know if I have room, we could have just taken an h out of this guy. It would be 2x plus h plus 6 all over h, and then they cancel. Same result. That's all. Just another way to do the same thing.
Okay.
Two ways to do the same thing. You can just cancel an h from each of them, or factor out the h and cancel it that way. Either way.
Do that because you'll get the answer without even canceling. Okay.
Either way.
Thank you.
All right. So, number 5, find the domain. Domain's always a weird thing. Really, nobody should miss domain. Domain's not hard, but I really think it's a lack of organization. I'm really struck by a lot of moving forward in math and I think science classes is organization. Just having your act together as far as having domain on your 3x5 card when you show up in a week. If you've got it, this will be a piece of cake for you. If you don't, you probably won't remember what domain is because it's kind of a weird thing. It's not a hard thing. It's just a different kind of thing. And you're not going to naturally remember it probably. Anybody remember it? I mean, I'd be impressed if you did. What is it? Yeah, on a graph, because we don't have a graph here. But if they gave us a picture, it would be the width. But we don't have a picture here. You're right, it's width on a picture, but we don't have a picture. What it is, domain is the allowable inputs. It's when I said you shouldn't put tinfoil in the microwave oven. It's what you can and cannot plug into a function. It's kind of a weird thing, like I said. Here's all you need though. Without all the theory, here's what you need to do. There's two things. If you have a denominator, then you say denominator, you cannot be 0, and you solve it. Number 2, we only look for 2 things. Do we have any denominators here? No denominators. Second thing, if you have a square root, you take the inside of that square root, and you say, hey, inside, what cannot be in a square root? Negatives, right? You can't take the square root of negative numbers. It's imaginary. You say inside, you have to be greater than or equal to 0. In other words, not negative. If you're not negative, then you're greater than 0 or equal to 0. You're greater than or equal to 0. You're not negative. And then you solve. That's it. So if you have that on your 3x5 card, in a week on exam day, you're golden. You just go up here and go, oh, domain? Let me see. There's my function. Do I have a denominator? No. Do I have a root? Oh, yes. Yes, I do. What do? I just take the inside, and I go greater than or equal to 0. Okay, I can do that. Take the inside. Just the inside, right? Not the root. I just pulled the snail out of the shell. Greater than or equal to 0. See, I just copied this form. No deep thinking, just being organized, though. Having your act together when you show up on exam day. This one is just simply the inside. Just literally say inside. Where you just pull it out of the root and then solve that equation for x. What do we do there to solve for x? Take the 3 over, add the 3 to both sides. And then 2x greater than or equal to 3. And then what do we do last step? Divide by 2. X greater than or equal to 3 halves. A, huh? So that's really pretty easy if you're organized. If you take the time to do a good job on your 3x5 card the night before the exam. You got to do a good job on that card. Go through the practice exam, put everything you need on there. That'll be an easy one. All right, next one. This one's not as easy. This one's more difficult. So number 6 here. So, okay, so the function equals x minus 5 if x is less than 1. 2 if x is greater than or equal to 1. This is those piecewise functions, they're called. It's graphs and functions that are in pieces. So we're saying, and remember this is y, right? Function values are y values. We're saying y is 2 for x values greater than or equal to 1. So what does that say? It says the height, remember y is the height. The height is 2 for x values greater than or equal to 1. So which graphs have that first off? Do you know what that means? Yeah, B and C. See how that's this right here and this right here? Do you see that? It's a height of 2. See how this is a height of 2? For x values 1 or bigger. For x values 1 or bigger. Does that make sense? You see what that's saying? For x values 1 or bigger, it's at a height of 2. So right now B and C are looking good. For x values 1 or bigger, it's at a height of 2. Isn't it? Now, actually, one of those is already out. What's wrong with one of them?
The dots.
Yeah, what's the problem? Which one's bad?
The B.
B is bad. B for bad. Yeah, B is bad. No open circle. Why not? Because it said greater than or equal to 1. Remember, equals means you're right on it. You're equal to 1. You're right there. You're solid dot. This is correct. Solid dot because we're less than or equal to 1.
What about the x minus?
So that's our answer. Our answer is C. It's not B on that. Yeah, we don't even actually need to look to the other part. And there's no E here. I don't think there is, right? Isn't there no E? I think there's no E. So it's got to be C. We've already eliminated the other ones. It's got to be C. I'll look at the other part with you too in case, it might be needed on the actual exam. But we already know it's C. Let's look at the other part, though, just to be thorough. So, yeah, x minus 5, that's y equals x minus 5. So y equals x minus 5 for x values less than 1. X values less than 1. So what's that? Well, you can make a table. That might be helpful. That's probably the best thing to do. And I'm going to plug into that table what kind of x values? Only x values less than 1. Now you can put in 1 itself, but circle it to remind you that it'll be an open dot when it gets to 1. It doesn't go right on 1, it just gets close to it, right? Because it's less than 1, but it's super close. A lot of people think the following, they think, well, I better not do 1 at all because it's not equal to 1. No, do 1, it's really close to 1, but circle it to remind yourself it's open dot there. It doesn't quite touch the 1. Plug in 1 though, what do you get? Y equals, I'll bring it right here. Y equals x minus 5. So plug in 1 for x. 1 minus 5, negative 4. So that means over 1 down 4. See? Perfect. Over 1 down 4, open dot. See how it has an open dot there? Now what about, can I put in 2? No. Only x values that are what? Less than 1. That's the mistake people make. They're not really understanding that off to the right are where you can plug in. You can plug into this function only for x values less than 1. This function only for x values greater than or equal to 1. It's in certain territories.
That's what will be 0, -5.
Yeah, so you want to plug in like 0. Plug in 0. Yeah, 0 minus 5, -5. And sure enough, see that dot right there? That's it, huh? That's 0 minus 5. It's headed down that way, isn't it? Yeah, that's it.
There's a lot of safety checks on it.
Does that make sense? So really, here's one more thing I could say to help, and that is
That's why D was, how people keep track of that.
this number they have out here for x. That's kind of like a dividing wall. That might help you. That's where it splits, right? To the right of x greater than or equal to 1, it's going to do y equals 2, right? Greater than or equal to 1, like 2 and 3, etc. And less than 1, like 0, -1, etc., it's going to do y equals x minus 5. It just means two different functions in two different zones. Make sense? This is x less than 1 zone, all the way here. And this is x greater than or equal to 1 zone. That's what a piecewise function is.